I would pay the $50 flow.
I mean, that's not even like that.
Okay, you guys about ready? All right. So hopefully you've got the notes that we went over last time, just continuing those. Okay, lines. Let me know if you can't see any of this. Lines from point slope. There's two sections in Deltamath that I'm going to cover sort of simultaneously here. So this is one, lines from point slope. This one's diagonal only. Lines from point slope, diagonal only. And then we'll also do lines from point slope that aren't necessarily diagonal. So a question we might see is, what is the equation of the line that passes through ordered pair 4, -6, and has a slope of -5/2. Okay, what is the equation of the line that passes through 4, -6, and has a slope of -5/2? A lot of times when you see that phrase, what is the equation of the line, you can use the point slope formula, which is y minus y1 equals m times x minus x1. So you see that phrase, what is the equation of the line? Generally, 90% of the time, you'll use this formula here. And so y minus y1 equals m times x minus x1. Just going to replace three things on that. We're going to replace y1, we're going to replace m, and we're going to replace x1. Any ideas what y1 is going to be? -6, yeah. And then x going to be 4. M, any ideas what m is? -5/2. Yeah, m is always the slope. So we can throw that there. These are always x and y for those ordered. So -6 there, and then 4 here. Just going to work that out, and that's going to be our equation. So y minus y1 was -6. So be careful when you do this, because we're subtracting whatever y1 is. We're subtracting -6, which is going to make that a plus. M is -5/2. And with the y at the front and the x inside the parentheses is just going to stay x. We're just replacing y1, m, and x1. So x1 is 4. So we got y minus -6 equals -5/2 times x minus 4. Distribute there. So this is going to be now y plus 6 equals -5/2x. And here we've got a negative times a negative. Be positive. And if you think of this as 4/1, multiplying fractions is usually pretty easy. You just have to multiply the top and multiply the bottom. So we know it's going to be positive. 5 times 4 on top. We've got 20. And then on bottom, the 2 times the 1. So 20/2. Make sure you guys let me know if you have any questions on any of this. So I'm just going to do y plus 6 equals -5 over 2x. 20 over 2 is the same as 20 divided by 2. Twenty divided by 2 is just 10. And the last thing that we want to do is get that y by itself on the left. How do we do that? Subtract 6, and then that's the end of it. So those cancel out. We've got y equals -5 over 2x. 10 minus 6 is 4. Okay, so hopefully not too bad. Just going to recap just a little bit. If they ask you what's the equation of the line, you're going to use y minus y1 equals m times x minus x1. Hopefully you can figure out what those three things we're replacing are.
Is there any reason why it wouldn't be a good idea just to plug the numbers into the slope intercept form and solve?
That's another way to do it. You can do it that way if you want. It's a slightly different. You have to figure out what b is and then go back and plug b in, but that's fine too.
Okay, just want to make sure I'm doing it wrong.
Okay. Okay, so that's the only example I'm showing on the lines from point slope diagonal only. Line equations from point slope. So I'm going to put a little star next to this one because most of them that you guys see will be like this last one that we did, but there's going to be a few exceptions. Here, what is the equation of a line that passes through -5, -7, and has an undefined slope. And so that's important. That's different than the last one that we did. Last one we had -5 over 2 for the slope, so we could just plug that into the equation. Here though, undefined slope, that means the line, you don't necessarily have to write this down, but the line is going to be straight up and down. These are undefined slopes. And you might remember from last time, these straight up and down ones, those are x equals equations. So x equals something, and in this case, what would be x equal to? -5, okay? X equals -5, and that's it. That's all you have to do on that one. Another one where slope is 0, sort of the same idea, but when slope is 0, it's a horizontal line. So let's see, what is one? Oh, and by the way, just in case this wasn't clear to everybody, but if it's undefined, it's x equals just a number. And the reason we know it's 5 is because, or -5 rather, is because they give us what x is equal to in the ordered pair. Okay, so what is one, or what is, go back. What is the equation of the line that passes through (6, -7) and has a slope of 0? Or I think they'll just write the number. A slope of 0. Okay, so if you're writing the notes, you might underline that slope of 0 part. The last one had an undefined slope. Undefined is straight up and down. Slope was 0, horizontal. So that would look like this. And those ones, you might remember, those are y equals equations. And in this one, hopefully, -7. So hopefully when you get to the line equations from point slope one, that second one, hopefully those go pretty quickly for you. And if you guys need time to write, let me know. Okay, line equation from 2 points. So here we're basically doing the thing that we did to start with, except they're not going to give us the slope. We have to work out what the slope is on our own. What is the equation of the line that passes through the points? Here we've got 7, 3, and 7, -6. Actually, let me do another pair first. So I'm gonna change these numbers. Let's do 3, -8, and -3, -6. Okay, we'll come back to those other ones because it's the point I want to make on those. So here we've got that what equation, or what is the equation part. And y minus y1 equals m times x minus x1. Replacing 3 things on that. y1, m, and x1. By the way, up here with these ordered pairs, 3, -8, that's always x first and then y. The -3, -6, always x and then y. And you can label them x1, y1, x2, y2. The first pair and the second pair. y1 is going to be -8, so we're subtracting whatever y1 is. M, though, I'm going to save that for now because we don't know what m is. I'm going to do that off on the side here in just a second. But x minus x1 is 3. So some examples we looked at before, they gave us what the slope was. They told us what m was. Here, they don't. But we can use the slope formula, which is y2 minus y1 over x2 minus x1. As long as you've labeled those ordered pairs, it should be pretty easy to do. Just plug in y2, -6 minus y1, which is -8. On bottom, x2, which is -3, minus x1, which is 3. So -6 plus 8, -3 minus 3. Close. -6. If it was -3 plus 3, we'd say 0. Okay. And you do want to reduce this. 2 and 6 you can reduce by 2. So this will be -1 over 3. 2 reduced by 2 is 1. 6 reduced by 2 is 3. And then that's going to be our m. -1/3. What's that? It's just the formula. You don't necessarily need to do that. You could do y1 minus y2, x1 minus x2. That's just generally the formula that you'll get. However you do it, you have to be consistent though. Y has to be on top, whatever order you subtract. And then if you do the second pair, y minus the first pair, you have to do the same thing on bottom. Second pair, x minus the first pair. And then from there, just y plus 8. On the right side, distributing that negative 1/3 times x. Negative 1/3 times negative 3, that's going to be a positive. Negative times negative, positive. And if you think of that as 3 over 1, you're just multiplying the top numbers, multiplying the bottom numbers. 1 times 3 is 3. On bottom, 3 times 1 is 3. So you end up with 3 over 3. 3 over 3 is just 1. And then last thing, we want to get that y by itself. So we'll subtract 8. And then y equals negative 1/3 x minus 7. Oh, actually, let me go back. Okay, so same instructions, but here we've got 7, 3, and 7, negative 6. Okay, so same instructions, but instead of the last 2 points we had on the last one, we've got these ones, 7, 3, and 7, negative 6. I'm gonna go ahead and label them, x and y, we'll call this x1, y1, x2, y2. So y minus y1. M we don't know yet, so I'll skip that. X minus x1, which is 7. They don't give us M, so we have to use that formula, y2 minus y1 over x2 minus x1. So y2, negative 6 minus y1, which is 3. X2, which is 7, minus x1, which is 7. So in this one, negative 6 minus 3, negative 9, 7 minus 7, 0. So I think we talked about this a bit last time. Okay, I'll just say it like that. It's undefined. If you got 0 on the bottom, undefined, 0 on the top, it's just 0. So let me go up just a little bit, just to remind you. If we have an undefined slope, if we ended up with a slope that had 0 on the bottom, undefined slope, that means it's a vertical line, which means the equation is x equals something. So back down here, if we've got an undefined slope, then we sort of throw all that out the window. We know it's going to be x equals something. And what's x going to be on this one? 7. Yeah. And if you look at both of our ordered pairs, x is 7 in both of those. So if you notice that, I wouldn't be opposed to anybody if you notice that where the x's are the same, I mean, this is probably the preferred method to do it. If you notice both of the x's are the same, just say x equals 7 and then move on. I'll give you another example. if you've got something like 4, -3, and 7, -3, what do you think the equation for that one might be? Yeah. The slope on that would be 0, right? Undefined on the x equals 1s, and then 0 on these. But yeah, hopefully you notice that, and maybe it goes a little bit faster for you. And you can do that if they give you multiple points where one of those points is the same. This one I'll go ahead and skip. I'll just say follow steps for lines from point slope diagonal. Okay, follow steps for lines for point slope diagonal only. You guys know what parallel lines look like, right? Parallel might look like this. You know, they're going the exact same direction, same exact slant. So the slant basically is another word for slope. If they're parallel, they have the same slope. Parallel lines have the same slope. Perpendicular, that might be something like this, and then they intersect at about a 90-degree, well, not about, they intersect at a 90-degree angle. So one of them is a positive slope going upwards. One of them is a negative slope going downwards. They're actually opposite signs, positive, negative. They're also reciprocals. If one of them's going up 3/4, the other one is going down 4/3. So it's the opposite. They're opposite signs. The slopes are opposite signs and reciprocal. So for perpendicular ones, the slopes are opposite signs. I know it's a little messy writing, but opposite signs and reciprocal. So an example of that might be if one is -3/4, the other one's positive, 4 is on top, and then 3 is on the bottom. Okay, so for a parallel, if one of them had a slope of, if one of them had a slope of 5, the other one would have a slope of 5. Parallel lines have the same slope, the same M. Okay, so what is the slope what is the slope of a line parallel to the line whose equation is x plus 4y equals 24. What is the slope of a line parallel? Clean this up just a little bit. What is the slope of a line parallel to the line whose equation is x plus 4y equals 24? Okay, one little side note here. I don't know if you guys have come across this yet, but if you got something like y equals 5x plus 2, anybody know what the slope of that is? Anything else? 5? Yeah, whatever. If you've got y by itself, you can tell what the slope is just by looking in front of x. So if y is by itself, we can tell what the slope is. Over here, though, the x plus 4y, it doesn't have y by itself. We do have to do a little bit of rearranging in order to get y by itself. And then we can figure out what the slope is. If it wants to know what the parallel slope is, it's just that same number. Get y by itself. If they're asking for parallel, we look at the slope, and then we change the sign and flip the number. So we'll do that here. Get y by itself. So starting with x plus 4y equals 24. If we want to get y by itself, we need to get rid of the x, and we need to get rid of the 4 in front of y. So minus x, I'll do that to start with. So x is gone from the left. We've got 4y all alone over there now. I'm going to put the x first, so negative x plus 24. Positive 24 there. And then still want to get y by itself. I'm going to divide 4. So you can write it, divide the whole right side by 4, or you can, I see people do this sometimes. They divide that by 4, they divide that by 4. Just make sure you divide everything by 4. So on the left, we've got y. Here, there's a number in front of x, -1. So you might want to write that out. -1 divided by 4, and then x, and then 24 divided by 4 just be 6. So -1/4 x plus 6. Okay, so it could, I can imagine somebody work on this for a minute and then forgetting what we're doing. Just getting y by itself so we can see what the slope is. It's asking us what is the slope of a parallel line. So if we want to know what the slope of a parallel line is, we need to know what the slope of this line is. The slope of this line is negative. Well, let me not circle that. This is the slope. If it says parallel, we're using the same slope. If it says perpendicular, we change the sign and flip it. So here they're asking for parallel. Parallel is the same. So -1/4. If it had asked for perpendicular, and there's going to be some of them that do, it would be positive. And you could write 4/1. I'm not sure if it'll take that as correct, because typically 4/1 you would just put in as 4. But 4/1 would still be correct. I just don't know how picky the software is going to be. So when they ask you parallel, perpendicular, you do have to get y by itself. Look at the slope and then parallel, perpendicular. Another one of those. What is the slope of a line perpendicular to, I'm going to put ... It's going to be the same sort of wording every single time. 6x minus 15y equals 360. 6x minus 15y equals 360. So we're going to get y by itself. Six x minus 15y equals 360. So getting y by itself, we're going to have to get rid of the 6x. We're going to have to get rid of the negative 15. We'll start with the 6x. So minus 6x on both sides. Negative 15y equals, again, I'm going to put the negative 6x first on the right. Negative 6x, and then plus 360. The y and the negative 15 are being multiplied here, so we've got to divide to separate them. Am I dividing by 15 or negative 15? Negative 15. And then negative 15 over here, negative 15 divided by everything. So y equals negative 6 over negative 15. Negative over a negative is going to be positive. 6 over 15, we could reduce both of those by 3. It's going to make this 2/5 x. And then 360 divided by 15. Is that 24? Not 24, that's not right. Is that right? Oh, okay. It's that part's unimportant because all we're looking at really is the slope. So if they wanted parallel slope, so this is the only important number, the number in front of x, that's the slope. If it wanted parallel, we'd say 2/5 for the answer. Since it wants perpendicular on this one, we're going to flip it and change the sign.
Over 2 minus.
Right. So 5 over 2, and then it's negative. Perpendicular slope. And I'll write that again. It's the opposite sign and reciprocal. Opposite sign, reciprocal. Okay, just a few more examples and then we'll be done. Okay, and this is the last Deltamath section in Module 2, graphing linear equations, or inequalities rather. Graphing linear inequalities. Inequalities are the less than, greater than, less than or equal to, greater than or equal to. Those are inequalities. You don't have an equals in the middle. Okay, so graph the inequality on the axes below. Graph the inequality on the axes below. So we've got y is less than or equal to negative 3/5 x minus 4. Okay. Couple things I want to highlight here. If you've got either one of, let me zoom in on this. If you've got either one of those symbols, less than, greater than. This is going to be a dashed line. So, you know, you'd have a linear line, but it'd be dot, dot, dash, 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 dash all the way, rather than the solid line that you typically see. Inequality is a little bit different. So dash. And then on the flip side, if you've got the same inequalities, but they've got that equal underneath, less than or equal to, greater than or equal to, these would just be solid lines. And you're going to have to graph these, so you will have to know the difference. This equation that we've got here, would that be solid or dashed? Solid. We've got the line underneath, the equal line, so solid line. And then the slope on this is -3/5. Okay. So on these ones, I'd say get y by itself. Do we have to do anything here? No. There's going to be some examples where that step's already done for you. Some of them where you have to rearrange the things in order to get y by itself, and then you can look at it, tell what the slope is. So this is the slope. -3/5. And then this point here, the -4. That's the y-intercept, I heard somebody say. So that's going to be 0, -4. So if you're graphing this, you'll start at the 0, -4, and then you would rise how much? You could go down 3, right? And then right or left? To the right 5. Okay, great. So with the slope, this is your rise. And this is your run. And I should probably mention, if you've got a minus there, you can put the minus on top and make the rise negative, meaning you're going down. You can put the minus on bottom, meaning the run is negative, so you'd be going left. It doesn't matter which, but don't do negative and negative, because then if you do that, you're basically turning it into positive, and you're changing it from what it actually is. But you can put minus on bottom or top, just not both. So we're going to start here. Or maybe I should say plot this first. Let me say it that way. Plot this first. So we've got that point. I don't know how well you guys can see this, but I went to 0, -4, which is just down 4 spots. And then we're going to rise -3. Going to go down 3. So from this little green dot, going to go down 3, 1, 2, 3, and then we're going to go right 5. 1, 2, 3, 4, 5. And remember, did we say this was a solid line or dashed? Solid. So let's see if I can. Okay, so something like that. And then okay, hopefully you guys are following this, because I got a lot of things I need to point out on that. Y is okay. Is y greater or less here? Y is less than or equal to. I'm going to ignore the equal part for a minute. But y is less. So hopefully all this doesn't get lost in there, but y is less. So shade, because you're gonna have to shade part of this graph. If y is less, do you think you'd shade above the line or would you shade below the line? You're gonna shade below. Y is less, so you're shading below. Because basically all we're doing is usually a line like this shows all the solutions. Every single one of those little dots is a solution to the equation that we're given. But since it's saying y is less, all of those are a solution and anything below. So we have to shade everything below. This is a whole lot of possible solutions. It's a whole lot of things that can be less than that equation. But so but that's as simple as it gets. Y is less, so shade below. And that just means you'll see when you get into the software, there's some shading option that you can do. As long as you shade below, should be good. So just to recap that one a little bit, get y by itself. Some of them that will already be the case, so you won't have to do that step. Decide whether or not it's solid or dashed. You just look at the okay. Yeah, you can just look at the inequality symbol to decide if it's dashed or solid. Hopefully you know how to graph well enough. Start with the point and then rise or run from there. And then however y is. If y is greater, you shade above. If y is less, you shade below. Okay, we'll do one more of those and then that's it. So same thing, same instructions. So 5x plus 6y is less than negative 48. We want to get y by itself. On the last one, we didn't have to do anything there, but here we got to get rid of the 5x, got to get rid of the 6, and then y will be by itself. So minus 5x. Five x is gone from the left. We've got 6y less than. I'm going to put the negative 5x first. Still trying to get y by itself, so divide 6. Divide everything by 6. So we've got y is less than negative 5 over 6, x minus 8, 48 divided by 6. One thing that's pretty important I should mention, I'll come back to this, but let me just make this point really quick. Because this only comes up with inequalities. If you had negative 3y equals, we'll say 6x plus 9. So if you, or I shouldn't say equals, let me change this in the middle. Let's say it's greater than, okay? What would the next step be if we want to get y by itself? I think I heard somebody say, are we dividing or subtracting? Dividing 3 or negative 3? Negative 3. Okay, so here's the important part. If you divide by a negative, that inequality symbol, that mouth that's open towards the left, if you divide by a negative, that has to switch. So that's going to change some things down the road. So don't forget that, because that would determine whether or not you're shading above or below. Here, if you're dividing by negative, switch that symbol. So this would be divide by negative 3, divide by negative 3. Y is now less than negative 2x minus 3. So let me write that explicitly. If we divide by a negative, it doesn't matter what the top number is, but if we divide by a negative, reverse the symbol. If we divide by negative, reverse the symbol. And then hopefully you can graph that. I'll go back up here and graph this one. Okay, so on this one back here, I'm just going to do a really quick sketch of the graph. We're going to start at 0, -8. 1, 2, 3, 4, 5, 6, 7, 8. So you got a dot there at -8. Then you're going to rise -5, which means you go down 5 and then right 6. But you might remember what I said about the minus thing. You can either put the minus on top or the bottom, or you can think of it like that. So I'm going to think of it with the minus on the bottom. So I'm actually going to go up 5 and then back 6. You can do it either way. So 1, 2, 3, 4, 5, and then back 6. Okay, I was going to see if anybody was going to catch that. Yes, does have to be a dashed line. I don't know if I'm going to be able to make little, I may not be able to do that. Yeah. But should be dashed. So I'll just do like that. It should be dashed. And then would we be shading above or below? Below. Yeah, y is less. So we're going to shade below. Y is less, shade below. So all that stuff beneath that would be shading. All right, so that's the last of the notes there. I do want to, let me stop this.